Yeah.
All right.
All right. A very good morning to everyone who's joining us today and will be watching this interview. And thank you for joining us in today's panel on digital manufacturing cybersecurity. My name is Dr. Susheem. I'm a postdoctoral researcher at the NYU Tunnel School of Engineering. I'm also going to be your host for today's discussion. First, I would like to thank the sponsors, specifically the National Science Foundation, thanks to whom events like these are possible. This webinar is going to be recorded and posted online onto our YouTube page. We are joined here today with Professor Mark Yampolskiy from Auburn University. Today's interview is going to be just one in our series of interviews where we interview experts in the field of digital manufacturing security. Professor Yampolskiy, thank you for joining us today, and we are pleased to have you with us. And thank you for taking out your precious time and coming to this interview for us. First, if you don't mind, could you give a brief introduction about yourself?
Okay. I started working on security of additive manufacturing around 2013, 2014. And around this time started publishing on this research direction. Actually, when I entered the research field, there was pretty much nobody in the field. So it was very interesting and demanding time. And this was time when you could really determine research directions for yourself and also for the field itself, where to go. And it was a very exciting time. So I stuck with this research field for a while now. I still think that it is underdeveloped, even 10 years after this field started. And many research questions remain unanswered. At the same time, we see situations that many agencies and companies are moving into using additive manufacturing, and because of this, security becomes more and more important. So,
all right, thank you so much. And it was interesting that you mentioned manufacturing cybersecurity, especially. So, coming from a computer science background, how did you feel the learning curve was like when you transitioned to and started focusing on manufacturing cybersecurity, and how did you end up becoming interested in this field in the first place?
okay, I was doing cybersecurity. I actually was at the time postdoc at Vanderbilt University, and was looking for a new research direction because I wanted to change research topic after my PhD. And because I was working in cyber physical system security, a jump from CPS security to additive manufacturing security is theoretically not that huge, because it is still 3D printer is a cyber physical system, but it has also a unique aspect, because cyber physical systems, you usually think about things like modern cars or drones. You probably know all kinds of fly-by-wire, drive-by-wire, robots, also cyber physical systems. So 3D printers themselves are cyber physical systems, but they have also some unique characteristics. It is not just CPS itself that might be under attack, but through the CPS, you can attack something else. My entry in the field was somewhat spontaneous or unintended, because I attended a talk of some material science experts who worked in additive manufacturing, and he talked about how difficult it is in metal AM to control quality of a part. And for me, as a young postdoc, I was just listening and thinking, okay, if somebody has difficulty to control it on purpose, as a security expert, maybe make life somebody difficult by sabotaging parts. And basically this was my original idea. And what you are doing when you have your what you think original idea, you go on Google Scholar on similar engines and try to find who is doing anything in this field. And I was really shocked that nobody has done by the time anything before. So, but I continued pursuing this. Regarding your question, how steep is the curve? It was much steeper than I expected, because you really need to learn a completely new, different research field in addition to what you already have expertise in, right? Okay, I knew cybersecurity, I knew what are cyber physical systems, etc. At the same time, 3D printing was completely new to me. So I spent about a year just learning about 3D printing, who has done what characteristics are contributing to quality of a part, etc. But only then I could do some reasonable research in this area. So.
Okay, and definitely your research has proven to be successful. And if you look at a Google Scholar page, the citations are, evidence of that fact. And
Yeah,
using that, yes, please go on.
Yeah, it is. Okay, if you are one of the first in the field, it is quite easy to get noticed by people who are coming after you. And but at the same time, you need to do good research, and you also have to write good papers. Otherwise, people just say, "Okay, let's move on."
Absolutely. And on that note, what would you say are some of your significant contributions to the field, or which you consider to be the important contributions you have made to the area?
I would say, for example, identifications that sabotage of a part or sabotage in a additive is a huge research problem, right? Because it is different than attacks on cyber physical systems. In cyber physical systems, if you attack cyber physical system itself. In additive, even though you can attack 3D printer, but it is rather through the 3D printer you are attacking parts that you are manufacturing, and through this part you are attacking system in which this part is installed. So basically you have several steps removed from actual effect when that will manifest, right? Your manipulations are distant from this manifested effect. Also, I would say that I spent enough time trying to consider both attacks and defenses. And this is where my security or cybersecurity background comes very handy, because in cybersecurity you train to understand that developing a solution without a solution like defense technique, without understanding how attack technique work is impossible. And in cybersecurity, you also learn early on to have adversarial mindset. This means that you are thinking, oh, if I would be an attacker, how would I do? How would I evade detection, etc. So this is a perspective that that I could bring to the field. Obviously, I needed to learn mechanical engineering, material science, but with this lens, okay, adversarial perspective, right? So, and therefore I done research both on attack and defender side. Some of probably most cited papers is on sabotage attack. This was collaboration between me and my colleagues from Ben Gurion University of the Negev in Israel. And back then it was the very first full chain of attack, basically from compromise through different stages up to destruction of a part. We sabotaged propeller of a quadcopter, and this sabotage led to destruction of a drone because propeller fell during quadcopter flying. So quadcopter fell to the ground and was destroyed. So this was one of the very illustrative example why security of additive is important from sabotage perspective, right? What is the danger of sabotage? Yeah, and we also used side channels. Side channels, these are typically in cybersecurity. You know side channels as unintended physical emanations of cyber physical process, and we use these side channels for detecting of sabotage attack, and still actively using for different reasons. I think that it is a very good approach for detecting sabotage attack. If you want, we can go a little bit deeper in this. Yeah.
All right. And talking specifically about manufacturing cybersecurity, what do you see as the top risks that exist in the field today, and how do you think legacy systems contribute to these security vulnerabilities?
Okay, there are depending how you're counting. Two most prominent security threats that are widely accepted. People just call them differently. Theft of technical data. Many people are calling them intellectual property theft. I would argue that IP is only a portion of technical data theft. And another one, sabotage attacks. And let me just give you some short example about why technical data theft, why I think that technical data theft is more important to consider from security perspective than just intellectual property. For example, if you are talking about intellectual property, usually it is design or maybe manufacturing process parameters. So manufacturing process is secret source, how you are manufacturing part. But at the same time, you might have some information like what is your resource utilization when parts are manufactured, who is the operator of the machine, etc. And if I am a bad guy who is attacking and doing sabotage, for me, many of these data points might be essential information. Because if I'm attacking, if I'm introducing some defect, I probably will select some time when nobody of operators is looking, right? For example, 2 or 3 in the night. And if you have this 40, 50 hours build, 2 or 3 in the night, it's probably a good choice to introduce a defect. So these are widely accepted security threat categories. There is one more when you are having somewhat strange situations that it is not really AM specific, but we are trying to find solution because AM is such an universal machine. This is manufacturing of illegal or unauthorized parts. So think about manufacturing of plastic guns or bump stocks, conversion kits, because 3D printers don't have any protections, any way to detect and prevent you from manufacturing any part at all. Therefore, as attacker, you only need to buy a 3D printer that is capable of manufacturing parts that you want to manufacture, right? But what we are considering as a problem, or we as security experts are trying to solve, is how do you prevent this? How do you detect that somebody is manufacturing parts that is illegal, and how you prevent this? I have seen only few works on this direction because it is extremely challenging. Again, we can talk about why is it difficult, why is it easy on attacker part to avoid various detections. But I know that recently Department of Justice started initiative together with industrial companies to try to address this, because many criminal organizations are using 3D printers for manufacturing such gun conversion kits. This is number 3, and my team, actually in collaboration with my external partners, we recently discovered that it is also possible to integrate additional information in STL design files. STL is the most popular design file format in additive. And this is another very strange security threat. Here you are not attacking 3D printing or additive manufacturing. Here you are rather using or misusing designs that are used in additive manufacturing to support other attacks. Just to give you an example, nowadays outsourcing becomes more and more prevalent and more accepted. Reasons are economical nature. You need to have very high capital investment for example, metal 3D printers. At the same time, you can just outsource and get part printed, just few parts at all. And at the same time, also on the manufacturer side, you want to improve resource utilization. You want to keep your machine running as much as possible in order to get to your return on investment point as soon as possible. And therefore, there is willingness and readiness on both manufacturer side and customer side for the outsourcing business model. And this means that you create a situation when sending and receiving design files, like STL design files, become somewhat usual occurrence. And we showed that with this integration in the STL design file, additional information, you can actually use this readiness for outsourcing as a vehicle for data exfiltration. I stole some design, I stole some information, I sent a design to shell company or even to myself and ask for manufacturing. It might be some Mickey Mouse or whatever figure or Darth Vader figure, and then inside of this innocent looking figure you are embedded some top secret information, right? So you can exfiltrate data, but at the same time you can also infiltrate data in secure environments. For example, I'm a bad guy, I need to infiltrate somehow my hacking tools into secure environment. I embed my hacking tools into Darth Vader figure. I download this from some Thingiverse on which I uploaded this prepared figure, and then it takes only a couple of hours to write a script to extract this data. So these are basically 4 security threats. You can look at each of these threats from attacker perspective, from defender perspective. And I would also add that there is also investigative perspective and also legal perspective. Yeah. So basically, my vision of the field and my understanding of the field and where we stand, there are problems that we are trying to address.
Fantastic. And I would also like to talk about standards. So you have been deeply involved with, establishing or in the standard community, and talked about the need for development of new standards. So can you talk about that in greater detail, about why there is a need for the development of standards and your work in that?
Yes, I actually established a group and currently technical leader of a group at STM International. This is, you might be familiar, standardization body for, among others, responsible for additive manufacturing.
Right.
And under F42 committee, we have a group running with multiple researchers from multiple organizations, including NIST. For example, a colleague from NIST is co-leading this group. And we have industry partners, we have academia. Obviously, I'm representing academia. we have representatives from agencies, and we are developing a standard that will provide guidelines for adopters of additive manufacturing, how to secure their system, or at least to understand what are the problems so that you can address the problems. The need is fairly clear. People who are involved in this group, including myself, we have been working in the field for about a decade, right? And we still learn from each other, and we still learn something new, ways of attacking system. We're still developing ways of defending system. So standard is here for basically newcomers who don't know this field. I mean, field of additive manufacturing security. And this is for both AM adopters or AM experts. If somebody is spending time, for example, if you studied additive manufacturing and you are entering the field, you want to establish your company, and then suddenly you need to deal with security and you have absolutely no background. Where do you go? Standard is one of the of the avenues where you should go. The same for cybersecurity experts coming from cybersecurity, having cybersecurity background. And like I said at the beginning, I had to spend about a year learning about additive manufacturing before I started even start thinking about what are problems without even addressing these problems and developing solutions, right? For these cybersecurity experts who are tasked and paid for securing additive, how does it do this, right? Just to maybe a side note, security of additive manufacturing is much broader than security, cybersecurity. So cybersecurity is an integral component of additive manufacturing security, but it is not all-encompassing. Cyber is just a portion, right? There are all kinds of cyber physical attacks, right? For example, the side channel attacks on stealing design file just by base examinations, or side channel based defenses like what I am working on actively. And therefore, standards are providing guidelines for newcomers in the field who are not expert in AM security, what to worry about, and how to address your specific worries. And just okay, we have right now a document in a fairly advanced stage, and we are trying to finalize it, hopefully in a reasonable time. But it took us probably 2 years work on this document, and these are people who have both expertise and experience in security of additive manufacturing to come up with this document. So it is not very easy even for people who are dedicated to this field to put together a document. So.
Yeah, understood. Sounds very exciting. And finally, how do you see the field of manufacturing cybersecurity shaping up in the future, especially in the next 5 to 10 years?
This is an interesting question. I would say I expect that we will, in the next probably 5 years, maybe sooner, we will see first real attacks. Actually, there are indications that attacks are already happening. We ran a survey recently, and if I right remember, 5 out of 55 respondents, roughly 9%, answered that their organizations has already experienced attacks, but they are not at the liberty to disclose any details. So I would expect that we will see more and more details of or disclosed, and more attacks popping up in the wild. I would also, from experience in cybersecurity, expect that attacks will find avenues that we have not thought of. This is a danger of security, to pretend that you know everything. Then you often surprised, because attackers usually find very creative, very innovative ways of attacking your system. I think that many companies, I know some companies that have already developed predominantly cybersecurity solutions, but I know some companies that are working on also cyber and cyber physical security solutions for additive manufacturing. So I would expect this entering the field. And I must also say that I would expect that we will detect new and discover new security threats that we have not thought of so far. So I still think that this field is very, very young and in its infancy, and we are likely to be surprised.
Okay. So finally, thank you so much, Professor, for your valuable time. Thank you for this very interesting and constructive conversation. I'm sure all our viewers will find this very exciting and very informative as well. And uh, all these videos and webinars will be uploaded onto our YouTube page. So once again, thank you very much.
Thank you for having me.
Thank you.